Welcome, everyone. John here, senior software engineer, 10 years of experience. And today we're doing some Leetcode. This will be an abbreviated session. I think I will go for 4 or 5. We'll see if we can get to 5. This is a Monday. I didn't do any Leetcode, I think, since Friday. And the most recent Kata practice was the 5th problem. So we'll see how my recall is on the 5th problem. I haven't done it many times. And the reason that today's stream is abbreviated is because typically we're abbreviated and we're starting a bit early. We're starting like 15 minutes early. So typically I stream 3 to 4 p.m. Eastern, but I have a 3:30 call related to getting a job, which is going to take priority. As we know, if you've been following along, the entire purpose that I'm doing these Leetcode streams is to assist with getting a job, interview preparation. So it would be natural that the call itself would take priority. Okay. That's the main call out. Yeah, maybe I'll do a sentence or two of just the overall job search itself. So this is week 2 of being laid off as a senior software engineer. In my 12 standard Kata problems, I've gotten to the position where I did 5, I think, successfully on Friday. And usually when I get to 6 confidently is when I start firing out applications, basically. But on Friday, I went ahead and fired out some applications. And I did some light social networking over the weekend in a matter of about 4 hours. So about 20 applications. And then I did probably on average 5 LinkedIn connection requests per application. So my goal is that I would like to connect with at least one of 3 job families: a hiring manager, a fellow developer, or a technical recruiter. One thing that I probably haven't mentioned enough in the past is I don't assume like 100% response rate. So the fact that I want to connect with one of these 3 individuals doesn't mean that I'm like sending 1 connection request per job post. Does that make sense? I'll do like up to 10. It's going to depend on availability. So some smaller companies, there may not be 10 people in the company. So I am even networking with some startups. But for your normal size company, which is going to be in excess of 50 people, and then the IT department or org will be in excess of 10 or even 20. And particularly at large companies, there's plenty of people to connect with. So I'll typically limit myself to 10. Like even if I could do more than 10, just for time boxing, I'm not spending too much time on this particular job posting. And so it sort of organically ends up between like 5 and 10 in most cases, and probably average around 5 when you include the smaller ones as well. Okay, and so of those connection requests, I was able, with about 4 hours of networking effort, I was able to generate 2 referrals over the weekend by Monday. So Friday to Monday, you can do a lot. Okay, so that's the situation of my job search now. And then I was thinking to progress over to behavioral prep. I am concurrently I'm starting to do behavioral prep now. So I've brain dumped my anecdotes into a Google Doc, and I'm slowly refining it into STAR method anecdotes, which I will then map to anticipated behavioral questions. And frankly, I really have not started sys design prep at all. So we're still 2 to 3 weeks out from where final loops would be. And so that gives you an overview of where I'm at with the kind of like overall job search and how the Leetcode fits into that, along with the other forms of round prep and the application rates and conversions and so on. I'll answer one question and then we'll dive into the kata. So Scolded Scald, thanks for being here on TikTok. By the way, tap the video and give it some likes so the algorithm will send it around. If you're here on another platform such as YouTube, thanks for being here. And hopefully you'll do likewise and tap like. If you're on TikTok and would like to view the whole screen, you can see the links in my bios to Twitch and YouTube, where you'll be able to see the full screen. I just hit 100 followers on Twitch. It's my smallest platform by following, but still a fun landmark. So that was fun. I hit 100 followers on Twitch over the weekend. Scolded Scald says, how do you get a referral from someone you only know from a friend request? This is an excellent question. So this is the technique of cold outreach, and there's a bunch of techniques here. Please do join the Discord where we can talk about this more. I have these networking scripts which will give you some advice about what to say by job family, whether it's a fellow SWE, a manager, or a technical recruiter. Some of the keys are that you are going to want to be concise and concrete and immediate and make them feel valued and appreciated. I think those are the 4 big keys. So how do we be concise? LinkedIn has a forcing function for this. Whenever you connect with someone on LinkedIn, you will have a button that says add note. So you click the button to add a note and you are bound to 300 characters. So you're going to be concise. You don't need to use all the 300 characters, by the way. If you can be even more concise, that's great. So you're concise, you are concrete, and you are immediate. So the immediate part is that you click that add note button. A mistake that I see a lot of people do is they will try to connect and they will wait for the connection to be approved. And then they will, as a second step, later DM. You've lost several days there on average because the typical approval for the connection request is going to take a few days. And then you'll need to message them. It may be a few more days before they read that. And it also makes the connection conversion rate fail at a higher propensity because the person has no context. Why are you adding them? Why are you adding them? So by being immediate with your message and being concrete with your message, first of all, you boost the conversion rate for the acceptance of the connection request. So they're going to accept more often. And they're going to reply with useful response much more quickly because you've saved the days of the back and forth. So be concrete, immediate, and concise, and then make them feel appreciated or valued. There are various ways to do this. Sort of one of the naive ways to do this is, hey, I found a typo on your website, and so I did you a favor, right? And so now you do me a favor. That's really transactional and elementary, I would say. Also, by the time you're at the level that I'm at, where you're dealing with seniors and staff and directors, the last thing they need is another to-do item. The last thing they need is more scope, more work to do, another person telling them, hey, fix this. Especially imagine telling a staff engineer to fix a typo on the website. That's way below their level. So some of the things that you're going to do vary at the juniors, vary by level. Okay, that's some of the nuance there. So as a junior, it might be appropriate to ask for a portfolio review or a resume review. In fact, I encourage that, and that's what's included in these scripts, in these scripts in front of us. Because the Latterly content is largely targeted at landing your first programming role. But at the senior level, what I've been doing, I've not been asking people for portfolio reviews. I've been asking for profile reviews. And here's a power move, is I assume that I'm a fit for their company. And I don't ask them hey, would you refer me to your company? I don't even ask that. I assume that I could fit somewhere at the company. What I do is I will take 2 or 3 job postings that are at a variety of levels. So maybe a senior, a staff, and then I've also even done MLE roles. So as a Python developer, I typically go for software, but I would genuinely, authentically consider an MLE role. And I'll say, for example, hey, you're a hiring manager on this team. Which of these positions do you think my profile is a best fit for? That's a power move. Think about that. Whichever one they pick, you've said I'm a best fit for this, right? Isn't it natural that you would refer me now? So that's one of the reasons it's a power move. It's kind of, and it also makes them feel valued because you're talking to them about something relevant and concrete where they have expertise. And people do have a natural desire to yield their expertise. It makes us feel productive and valuable when we can yield our expertise. In addition, if they successfully place me at most of these companies, they will have a referral bonus. So there's a natural incentive where they want to truly guide me to the best fit role. Okay, so those are some of my tips. And then, yeah, I also did a video on this recently. You can check my YouTube channel where I give, even beyond the networking scripts, I give literal censored versions of what I've specifically been saying. So if you go to videos, how to ask for a referral, right up there. But basically, I typically use LinkedIn and then I'll add the notes and it's going to be concise and related to specific action items where I'm trying to get it's very clear that I'm trying to get a reference, but it's also very clear that it's okay if you don't want to refer me for role A. So here's another mistake. Hey, here's a job I like. Would you refer me? Like it's a binary outcome, like yes or no. You see why that's a problem? Because it's like maybe the answer is no. But if I ask you, hey, here are a few roles that I'm interested in at your company. Can you give me more information about the skills matrix for engineers and which one do you think that I'm closest to? They can say no, but it's a lot harder to say no because it's not. You're like, does that make sense? Like I'm not. It's harder for them to say like you don't even have any of the skills on the matrix for any of these roles. It's the this or that close in sales. I'm sure it's something like that. Yeah, I'm really understudied at sales techniques, but it does feel like kind of like a sales technique, except that it's authentic and genuine, right? That's a key here. I shouldn't bring up the MLE role if I'm not genuinely open to it. Um, Never ask a question they can say no to. Yeah, basically that's the approach is like make it easy for them to say yes, make it hard for them to say no. And also try to create a question such that even if they say no, you still get some kind of value out of it. So even if they say, hey, John, here's the skills matrix at senior. Unfortunately, we have a really high bar at our company. So even given your 10 years of experience and so on, I don't think you're even appropriate for the senior level at this company. I've still gotten a couple things. I've still gotten a LinkedIn connection request and data about the skills matrix. Now, what I can do is very often, not always, but very often, I can go get a second opinion even at that company. Very likely, this is not the only engineer with context at the company. And I don't think it's a problem. I think it's a great idea to try to connect with multiple people at the same company. Because if you want to get information about which role am I best fit for, it's actually a good idea to get multiple perspectives on that if possible. And so if one of them doesn't want to refer you, like that's fine. If you get one of the referrals and then you're getting all sorts of skills matrix data or whatever else from the others, at the end of the day, you have more connection requests and a whole lot of context that's going to helpfully benefit you at the behavioral stage of the interview or potentially in many other ways. So as a job search candidate, don't fear the cold outreach. Like even if they say no, if they accept the connection request and say no, you still grew your network. It's like really hard to find a mode of failure if you're doing this. And then if you're doing it at volume, again, remember I said 20 companies and like probably on average 5 per company. If I try to reach out to 100 people, even if the majority of them like don't even accept my connection request, um, what maybe I'm still getting like 40 additions to my network and like there's still a ton of value being added. So don't dwell on like, hey, this person didn't accept my connection request, this person said no. Don't dwell on it. Play the numbers but be genuine about it, and that combination of being like authentic but also strategic, that combination is just going to help you succeed at the job search. Okay, great. I'm glad we went on that tear. Let's do some Leetcode, eh? Thanks for being here. Sales has to be genuine or it won't close. Maybe so. Maybe so. I think it certainly helps, right? I've heard it said the best sell is an honest sell, and I sure hope that's true. Okay, to some input arrays not sorted. Look at my daily check-in point from Leetcode. Thanks, Leetcode. Given a one-indexed array of integers, the integer array name is numbers. This array is already sorted in non-decreasing order. So we can have duplicates. 1, 1, 1, 2, 2, 2 is an example of an array sorted in non-decreasing order. Let's find two numbers so that they add to a specific target. The target is given as a distinct argument in the signature of TwoSum. Return the indices as a two-length array, and these are the one-indexed indices. The tests are generated so that there's exactly one solution. We can't use the same element twice. We must use constant space in memory. And because there's exactly one solution, not only do we not need to worry about duplicates, we also don't need to worry about the absence of any solution. Like there's guaranteed to be a solution. So we don't need to handle the sad case where there's like no answer. Okay, so given this data, we know it's sorted, and because it's sorted, this should be an immediate cue that we probably want to do some sort of interval or window-based scan. And indeed, in the case of two-sum, we can simply use a left and right pointer at each extrema of the array and have a window sum that is the sum of those edges. And then if we want to increase the window sum, what do? We move a left pointer to the right. If we want to decrease it, we move the right pointer to the left. And that way, we can control whether we want to go up or down towards the target up to the point that these pointers cross. If the pointers cross and we still haven't found the target, we simply won't find the target. However, again, we're guaranteed to find the target based on this particular prompt. So let's go with that. Let's start making our left and our right. So left is going to be 0. Right is the length of numbers. -1. So we'll use the 0 index for reaching out to the array, but we'll eventually return the 1 index form to comply with the prompt. My while condition. So I'm going to scan the whole thing with a while condition, and it's going to be based on the idea that these things should never cross since we're guaranteed to have a solution. So I'll get my current sum, which is going to be left plus right, but that's a pseudocode. Those are indices. The literal here would be the left of numbers plus the right of numbers, the right index of numbers. And then there's a few conditions. So if above, again, this is a pseudocode, else if below. We're doing this all in Python. Syntax will vary slightly based on your language. And then in this else condition, match found, let's return the 1 indexed form. This should be the entirety of the solution. Now let's just replace the pseudocode with the literal. So how do I know that my current sum is above? It's because the target, which is distinctly provided in the argument, is going to be less than my current sum. That means I'm above. And so what I should do is decrease my window sum by moving my right pointer to the left. So right minus equals 1, else left plus equals 1. And the below case will be that the current sum is less than the target, or you could write it either way, right? I can also say that the target is greater than the current sum. Those are equivalent. You good? What's up? You good says, bro. What's up, bro? Thanks for being here. Why are you calling them pointers? Because they literally just point to an index. They are entities that contain so they don't contain the value under concern. The value under concern is left of numbers. That's when I'm trying to generate my sum, I care about the value there. The left is only a lookup tool on numbers. So because it's a lookup tool, that's why we call it a pointer. Does that make sense? And these pointers, by the way, take up constant memory. So the complexity analysis perf is O in because in the worst case, I check every value and numbers, and then mem or space complexity constant O of 1. So they're literally pointers like in C. They are literally isomorphic to pointers. So you can look up this term isomorphic. So you can compile Python to C. There's a tool called MyPy, for example. This is like my favorite way to, if you really need to squeak out performance from Python, you can use MyPyC. There's some other ways to do this, MyPyC. There's other ways to do this. There's a tool called Numba, and there's like other ways to do this. But MyPyC is probably one of my favorites because you get strong typing. If you compile this to C, you will literally get a C pointer at that time. You will literally get a C pointer at that time. So what this literally is a Python integer. And if you really want to get into the weeds, there are some differences between a Python integer and a C pointer. There are some differences. But they're isomorphic. They're equivalent. So that's why we go ahead and use the word anyway. Does that make sense? Great questions, by the way, Scolded Scald. Good to know. Thank you. Very, very welcome. I don't know that anyone has asked me that question before the whole time that we've been doing these Leetcodes. So that was a fun one. Okay. We need to run it. Accepted. Submit. Accepted. Okay, so we got through 2. Sum. Let's continue on the Kata with 3 sum. We're doing these same problems over and over. It's a memorization-based approach. The idea is that you learn abstracta as a second step to learning concreta. That's the Leetcode approach. I don't want to tell you what a hash map is until you already know what a Python dictionary is. Why the hell do you care what a hash map is? The reason that you should care about a hash map is when I tell you this is a code segment in Python, I would like you to implement it in JavaScript. And then you have to go, well, shit, like what is the JavaScript equivalent of a Python dictionary? Now it's worth telling you about DSA. Now it's worth telling you about hash map. Does that make sense? So I'm starting with the concreta and I'm literally memorizing the concrete problems so that I can impose pattern learning on the concrete as a second step. That's why the Leetcode approach is fundamentally different than like a computer science program where they might lead with the abstracta. I disagree with that approach. Project-based learning is superior to traditional lecture. There's tons of research on this, and hand in hand with that, carrying the analogy further, we lead by concreta. Even in your programs, I don't want you to prematurely abstract. Even in your software, I want you to start by solving a problem and Yagni, babes. I want you to abstract and create the intermediary class layer only when the program scope forces you to. Do you use Codeforce? I think it's better. No, I don't use Codeforce, and I don't think it's better. And you don't have to take my word for that. If you go interview at Facebook, they will tell you, like, practice on Leetcode. Are these Kata on the website? They are. They are. Blog number 3, Laterally Leetcode Kata. By the way, if you get hung up on a solution, you can go to the blog number 7. And here are solutions in Python, Java, and JavaScript as a video series. If you would like to contribute text solutions, there's an open GitHub issue. That's sort of a work in progress. Pull requests are welcome. But in the meantime, you can look up the video. A lot of these are going to be Leetcode. Shout out to Leetcode. Cool. I think we have 5 more minutes. Let's try to get through 3 sum. So we are given an integer array nums, and we can return all the triplets. For example, I of nums. So now we're returning the value. We're returning I of nums, not I, not the index. We're returning the value. And we're going to return these values such that their indices are distinct. So there might be duplicate values in the returned triplet. There could be duplicate values, but those values will be associated with distinct indices. Does that make sense? Okay, if that didn't make sense, let's take a look at some of the examples. Oh, actually, they say the solution set must not contain duplicate triplets. So in addition to being distinct indices, they also must not be distinct. They also must not be duplicate triplets. So it's like doubly deduped on the value. Here's an example, -1, -1, 2. Why is that a solution? Because it adds to 0. So in all of these cases, we want to add to 0. There is no separately provided target. It's just a target of 0 in every case. And there could be multiple solutions, and there could be empty, there could be no solutions, empty set. Okay, so a few different wrinkles in this 3 sum, but the overall approach, take 2 sum and wrap in a single loop. Time complexity there is O of n squared. Memory complexity is constant because the external loop will just be an additional pointer. Okay? So here requires sorting, but the nlog n sort isn't a binding constraint on performance, because O(n) squared is going to be slower than n log n. So let's go ahead and sort just to make sure we don't forget. I think I can just do that. We'll set up results as a set for auto deduplication. So we don't need to manually worry about deduplicating the triplets. We'll just provide them as tuples. Okay. Why tuples? Because tuples are hashable. They're hashable, unlike the lists in Python. How do you learn to calculate memory and time complexities? I haven't run into those in my classes. So what level are you? You're like a sophomore level? You will, in a computer science program, you will definitely learn about asymptotic complexity, but it's going to be probably an advanced topic. I don't know what year they teach it these days. So how do I learn about it? Mainly through Leetcode. If you loop over an array, then you have taken up a number of calculations equivalent in length to the array, right? And so if you have a situation where for every index of the array, you need to loop on that index, then you will have a situation where the number of computations you must run is equivalent to the length of the array times the length of the array, which would be n squared. In a simplistic mental model, you can just slap O of on there, and voila, there's your asymptotic complexity. And that's pretty much good enough to pass big tech interviewing rounds. There's distinctions between best case, worst case, average case, median case. You can pretty much like ignore all that stuff. For big tech interview rounds, pretty much they want to talk about the worst case because they want to know about the binding constraint on the system. That will be the primary determinant of scalability of a system at large volume, which is what companies like Facebook care about. When you hear this term like big data or web scale, the speed of your system is going to be determined by the worst case. There's this thing called, I think is it Gresham's law? I get all these laws mixed up. Whatever can happen will happen. Oh no, this is like an economics thing. Whatever can happen will happen. Murphy's law? Yeah. So Murphy's law, whatever can happen will happen. And there's a statistical application of this where when you think about performance testing, we very often care about nines. So we'll care about the P90, the P99, the 99.9. And when you get into like high availability, we ask like, how many nines of availability do you have? 3, 4, 5, 6, 7, whatever. So like 7 nines of availability is like Amazon standard. And I forget if Amazon would consider that like, I think, yeah, Amazon would call that high availability if you have 7 nines of availability. But basically, if you're at web scale with billions of users, 7 nines, still someone is going to fall through the cracks. You see what I mean? So that's why we care about these nines, or like that's why we care about these worst case constraints, because basically in a web scale system, the worst case performance is the performance, because you're like always going to run into these things at that scale. Did that make sense? Yeah, nines, like the number 9, like 99% of the time or 99.9% of the time. These are like your worst case performance metrics. What it means is if I give you my 99 percentile performance, that means that 99% of the time I'm this fast or faster. So only 1% of the time will I be slower than that. And if I do 99.9, which is 3 nines, only 0.1% of the time am I slower than that. So this is basically an empirical measure of worst case performance. So these would be the empirical measures that are associated to what we're doing here. These are kind of like your theoretical measures or your abstract measures. So that's one of the many reasons we call this a DSA, like an abstract coding problem. And this time complexity is helping us understand the worst case performance with like a theoretical lens. So n squared doesn't actually tell you how many seconds, but it tells you, given two implementations, how relatively fast will they be? And you need to plug in numbers there. So you need to like take an empirical measure of n. So I give you this, and then you tell me like, what is your average nums length, right? What is your average nums length? Now I can give you a more concrete relative measure between two implementations of performance. Still, that's going to be a relative measure. If you want an absolute measure, now you need to go into like actually do performance testing, where you like set up timers and stuff, which is like awesome and important, but a very different skill set than what we're doing at interview time. I'm loving all the questions. I don't know that we're going to get through threesome. That's okay. We'll get, I have 3 more minutes. We're not going to get through threesome. No, please don't apologize. Don't apologize. I can go do more Leetcode practice on my own time. So this is equally for the community. So I'm very glad to have your questions. I'll just do the pseudocode. I can do the pseudocode for the rest of it in a couple minutes. So the approach here is I'll set up an outer left IDX. And that's going to be 0. And then I'll say while my outer left IDX is less than the length of nums. Here I'm going to call toSum and deduplicate or like fast forward duplicates. And then I'll eventually return results. Here, let me define toSum. We're going to add self because this is on the solution class. It's on the same class. Here, I need to have my, what do we call this thing? When it adds to 0, complement. We want all 3 of these to add to 0. Therefore, I need the complement, which will be my target for the inner 2, so that across the 3 members of the set, it'll add to 0. That's why we need to calculate the complement via the outer left index. Does that make sense? So here's nums. So the complement is going to be the opposite of the outer left index at nums. Because if I can find the opposite, then it will sum with the value itself to 0. That's why I want the opposite, because the target is always 0 under this problem. Okay, so here's toSum, and then I'm going to need the complement. I'm going to need results and this index. Do I need anything else? Maybe not. Maybe that's all I need. So my target is going to be the opposite of the complement. My left will be this index plus 1. Because I don't want to explore all of it every time. I just want to look at the window to the right of the outer wrapper. And that's how I'll eventually be able to explore every possibility, because I'm collapsing that window. The right is the same right. That's just the length of nums. Oh, I need to pass nums itself. Oop, did that wrong. Okay, we'll just say that I set up the function correctly. Like I haven't actually called it, I pseudo called it. So here is right. Now we have right and left, and then it's the same toSum we did previously. So while left is less than right, we want to get some, get some. If above, else if below, else match found, return sorted, or like not return in this case, we want to append sorted tuple to results and fast forward dupes. You want to fast forward at both levels, the toSum level and the threesum level. And if I'm not mistaken, that's the solution. All right. So that's going to be the pseudo-coded solution. Probably take 5 minutes to write down the actual code, maybe a little bit less. Fast forward, yeah. Let's see. Do I have 2 more minutes? What does it mean by fast forward? So I'll give you, okay, I can do 2 more minutes here. Here I'll say self.toSum the right args. So that's still kind of a pseudocode. But now you will see what I mean by fast forward. We're going to skip calling toSum a bunch of times. That's what I mean by fast forward. So while we're in bounds, so I'll replicate this expression, which is making sure that we don't have an out of boundary error on the index on the array. So as long as this is true, we'll never go out of bounds of nums. Okay, so we're going to reproduce that expression. And while I have the same complement, then I shouldn't call toSum because it's just going to be the same result over and over. That's what I'm fast forwarding or skipping. So while we are in bounds and while the complement remains, then I want to increment my outer left index. So how do I know that the complement remains? This is equal to that. That's what I mean by fast forward. Does that make sense? So the complement is not changing, so I'm wasting compute by calling toSum in this case. So let me just skip over it. Thanks for being here. Hope you'll join the Discord. So you can go to latterly.io. It was a great conversation. Scolded Scald. Great conversation. So latterly.io, it's open source. You can sign up for free. And you don't even have to sign up actually to join the Discord. It's there under the community tab. If I didn't get to your questions during the stream, come on by over there. Also, if you're interested in contributing to the open source project, got about 100 open issues. And I don't know, maybe 10% of them are good first issues, kind of beginner friendly. So drop by the Discord and chat, and I can give you some of the ones if you're interested in that.